Hello and welcome to my first ever YouTube video. Today I'll be showing you how to make a simple game of Connect4 in Java. First of all, let's talk about the game. The game is played on a 7x6 board with two players, each having a color red or yellow, and yellow has the first move, as you can see over here. Each move, one player drops a piece from the top of the board, and the piece lands on the lowest available position on the board, as you can see like this. And also each turn, the players alternate from dropping their own piece from the top. As you can see over here, if I drop two pieces on the same column, they stack on top of each other. And if I play a regular game and it gets to 3 in a row of yellow and I want to put another yellow in the next column, it becomes 4 in a row of yellow and there's a line connecting all four of them, and the piece hovering on top of the board becomes green. I just showed you what it would be like if there were 4 in a row horizontally, but over here I have 3 in a row vertically, and if I just place another yellow on top, it becomes 4 in a row vertically, and again the piece turns green on top. In my implementation of this game, there's a small animation to drop the piece to the bottom of the board, but otherwise there's no serious graphics in the game, so you can customize the game however you want, either by adding better animations or more colorful graphics. Now that we've talked about how the game works and how it's played, let's actually code it. The first thing we have to do is import the javax.swing package and the java.awt package for the graphics, like graphics class, the colors, etc. We also have to import the java.awt.event package for getting the user inputs from the mouse and running the game timer. Java.util package for basic utility classes like arrays. After importing, we make the class header for the main class Connect4, which coordinates the board with the mouse inputs and the game timer. For the header of the Connect4 class, we have extending jpanel so that we can see things on the screen, and we implement action listener for running the game timer, and mouse listener and mouse motion listener to get the inputs from the mouse from the user. Inside the class, there are 6 final constants that dictate the size and positioning of the board. The width and height variables are the pixel values of the actual width and height of the JFrame that is visible on the screen. The width unit and height unit are the pixel values for the unit of width and height on the board, which are also the width and height of each grid location on the board. Board length and board height are the number of rows and columns on the board. In this case, the board length is 7 because there are 7 columns, and board height is 6 because there are 6 rows. The constants are calculated in the static block of the class over here because they are static final constants. The preferred width, preferred height, and the number of rows and columns of the board are initially put into the initial width, initial height, and board length, board height variables. And there's a temporary width and height variables just to prevent rounding issues, because integers in Java round off and do not allow precise division. The width unit is calculated so that they're exactly board length plus 2 number of width unit inside the width of the frame, so that you can see the number of columns plus the margin of width unit on either side of the board. And the same calculations are made for the height unit, except with the height of the frame instead of the width. In the main method of the class, which is the first method to be called in the program, a new Connect4 object is made so that the constructor method is called of the Connect4 class. Inside the constructor method, first the background of the panel is set to white just to have a clean canvas on which to draw the graphics. Next, there is a basic setup of the frame, which includes setting the title, setting the width and height, which are already initialized in the static block, adding the panel to the frame, setting the close operation to exit on close, and setting it to visible. Next, we start the game timer to execute every 10 milliseconds so that the game will keep redrawing and updating the state of the game. You have to say specifically that's the javax.swing timer, because there's another timer in another package, and it's best not to get confused with the other timer because that has different methods and does different things. The listener is set to this because the actions to be taken every 10 milliseconds, like redrawing and updating the state of the game, are defined in the action performed method down here. Lastly, in the constructor, we register the mouse listener and mouse motion listener to the frame so that the user can provide the program with input through the mouse. Now let's see all of the methods that we need to implement from the interfaces that we implemented and the class that we extended above. Firstly, the action performed method is the one called by the timer every 10 milliseconds in order to update the screen. So all we need to do is repaint the panel in order to show what is now on the screen. The repainting calls the paint component method over here, which is supposed to paint everything that is on the screen. And in this method, we just have to give the task to the board and call board.draw and pass in the graphic, since the board is what has all of the information needed to draw itself. Next, when the mouse is moving around the screen, we want the piece that's hovering around to follow the mouse around the screen. In the mouse move method, we call the board's hover method and pass in the X value of the mouse. We don't pass the Y value of the mouse because the piece is always at the top and the Y value stays constant no matter where the mouse is. Next, when the mouse is pressed, we need the piece to drop down to the bottom. So we just call the board.drop method so that the piece drops to the bottom or wherever the lowest possible value is. There are a bunch of other methods that come from the mouse listener and mouse motion listener interfaces, but we don't need those, so we just leave them empty. Now let's move on to the board class, which takes care of all of the tasks and attributes of the board that is shown on the screen. This is a static class, since there will be only one board per instance of the game, and this also means that all of the fields and methods will be static. For the field variables, we have a 2D array of colors called board, the colors of all of the players, whose turn it is, the hovering piece's coordinates, and whether the game is finished or not. The 2D array board is a virtual representation of the board, with each grid coordinate being a separate color so that we know which colors should be drawn in which places. This could have been done with also a 2D array of integers, for example, but then each integer would then have to have been translated into a color anyways, so we might as well store it in a color directly. The array of colors represents all of the players who are playing the game. For example, in my setup where there are just two players, yellow and red, this array will be initialized with yellow in the 0th index and red in the first index, with yellow first because yellow has the first turn. Hover X and hover Y are just the coordinates of the hovering piece above the board. This integer turn represents whose turn it is, and this is the index in the array of colors called players, so that whichever index it is, that is the player whose turn it is currently. In the static block of the board class, just like above, we have to initialize all of the static field variables. The board is initialized to an empty 2D array of colors, with the dimensions of the 2D array being the board length and board height that were set earlier in the static block of the Connect4 class. The board is then filled up with the white color, since in the beginning of the game, no pieces have yet been dropped from the top and there's just an empty board. The array of players is set to be yellow first and then red, since there are two players and yellow goes first. But there can even be more than two players and different colors for each player, as the colors are completely arbitrary. For example, you could have a third player whose color is blue. Finally, the turn is set to 0 so that the first player to make a move is the first player in the array of players, whichever that is set to be. In this case, it is yellow. The first big method in the board class is the draw method. This is called from the paint component method above, and it takes in a graphics object called G. The first thing it does is just sets the anti-aliasing to on so that whatever shows up on the screen is nice and is not pixelated. Next, there's a big for loop that pretty much draws everything on the screen. There are two main functions of this for loop. The first is to draw all of the lines, like the vertical lines, separating all of the columns. And the next is to draw all of the pieces that are already on the board. First, the loop draws the vertical lines by having the I, which represents the x coordinate of the lines, start from width unit and end at width minus width unit, which creates the buffer on either side of the length width unit. and having a width unit increment so that it goes every width unit pixels on the screen. Then it just draws a line from the top to the bottom, the top being height unit and the bottom being height minus height unit. Next, the loop draws the pieces on the board by first getting the color and setting the color of the graphics to the color at that position on the board, and it accesses the board over here. And then it fills an oval with a 5 pixel buffer from each of the corners, and then it draws a black outline around the piece as well. At the end of the loop, the method just draws a horizontal line at the bottom, which is this line that all of the pieces sit on at the bottom of the screen. After all of that is drawn on the screen, the method takes the color of the current turn and sets the color of the graphics to that, or to green if the game is done, and draws the piece above the board at the hover X and hover Y position, and then again draws a black outline around the piece. After all of that, if the game is done, then the method just draws a black line connecting all 4 pieces that are connected. Next is the hover method, which is called from the mouse move method above, and this X represents the X coordinate of the mouse on the screen. First, the mouse is aligned with the closest vertical line to the left of the mouse, and then it is bounded to the left by width unit and to the right by width minus 2 times width unit, so that the piece stays on top of one of the columns on the screen, and then the hover X is updated to that mouse coordinate. And the hover Y is always 0 since the piece is always hovering at the same location above the board, no matter where the mouse Y position is. The next method is the drop method, where the piece is dropped from the top of the board to the bottom. The first thing that the method checks is that if the color is not equal to white at the top of the board, that means the whole column is filled up, then you cannot drop the piece down that column and it just returns. Next, a new thread is made so that 2 pieces can fall down from the top of the board at the same time, like this. If the new thread was not created, then the animation would run all on the main thread, and even if the mouse was pressed somewhere else, the main thread could not go and run the animation on the other piece. Inside the run method of this new thread, first the color and the X position of the piece are stored in local variables, so that if another thread changes the values, we won't care about that inside of this thread. Then the main for loop for the dropping animation is here, running from the top to the bottom, and while the current position of the piece is not white, which means that the position is not already taken up by another piece. Firstly, the current position is set to the color of the piece so that it shows up on the screen. Then after some set number of milliseconds, in this case 200 milliseconds or 0.2 seconds, the piece is erased from that position. After this, the piece is drawn onto the next position immediately, since there is no delay from this iteration of the loop to the next, and this repeated erasing and drawing gives a feeling of an animation. After the piece reaches the bottom or the lowest possible position on the board, the piece is just drawn there, and this is outside the loop, and the animation is done. Once the piece reaches its destination, the method has to check whether the game is done or not, because there has been an update to the game state, and so the check connect method is called with the destination position of the piece. Outside of the thread, just whose turn it is updated, since the current player dropped his piece already, and the next player in line, or the first player if all of the players have already moved, is the one to have his turn next. We have to check if the game is done every so often in the method, like over here, here, and here, because if the game is done from another piece that is dropping before, and 4 pieces are connected, we want to stop the animation and stop the current piece from falling, so that no confusion happen around whose piece dropped first. Next is the check connect method, which is called from up in the drop method, and this checks whether 4 pieces on the board are connected from the origin position of the X and Y. First, we have to check if the game is done for the same reasons that we had to check up there, because this is also being called from the anonymous thread that we created in the drop method. Then the search method is called, which actually searches for the foreigner rows, and that is stored into a point pair. If the pair is not equal to null, that means a foreigner row has been found. Then the P1 and P2 points are updated, and we remove the instance of this Connect4 game from the frame, and then we set the game done to true because the game is now done. This point pair is declared all the way up here outside of the board class, but all it is basically just a pair of points, P1 and P2, and you can call the constructor method by passing in two pairs of x1, y1, and the P1 and P2 are just updated from that. The final method is the actual logic for searching for the foreigner row in the board. First, the color of the piece at the origin point I, j is stored over here in color so that we know what color we are looking for when we are searching. There are also the left, right, up, and down variables that are the index variables for their respective directions that we are searching in, but they're just counters like I and j. To search horizontally left to right, the left variable is pushed as far left as possible while still staying the same color as the reference color, and same for the right. After that, if the difference between the two is at least 4, then a new point pair is returned with these two variables left and right because the foreigner row has been found. The same idea is used for searching up and down, but since there is nothing above the piece, since it just got dropped from the top, the only way it is pushed is down and it only searches downwards. The same idea is used for diagonal searches as well, except instead of going only left, the loop goes left and up at the same time and also bottom right. This switches for searching diagonally in the opposite direction. If any foreigner rows are found, they are immediately returned. So if we reach the end of the method without returning anything already, just null is returned, signifying that no foreigner rows were found. And that is it for this tutorial. All in all, the whole file is 212 lines long, and it is not too easy to follow. So if you got lost at any point, please go back and watch over the parts that you missed. Or you can directly download my code from GitHub, and the link will be in the description down below. Also, this code is completely flexible and not hard-coded, so if you want to add anything extra on top of what I have here, feel free. A few suggestions might be to add in some networking so that you can play with a friend over the internet, or to add some nice and realistic graphics. If you have any questions or comments about the code, or any suggestions about how to run my videos, please leave them down in the comments since I am open to any constructive criticism. If you liked this video and need help with anything regarding math, physics, or computer science like Java, you can contact me at chatterjeetutoring.com. The link will be in the description. If you like this video, please leave a thumbs up and subscribe to my channel. That's it for this video. See you in the next one.